OK。
好的，现在同学们都慢慢的在加入。Daniel 老师那边应该也能看到，我们稍稍再等一等，等所有的链接都全部建立完毕以后，然后我们就开始。对，现在陆陆续续大家进来。对，感谢各位家长和小朋友，然后到参加这个机器人的兴趣学习小组。然后呢，现在 Room 正在建立链接，然后陆陆续续的还有很多的这个小朋友，然后再进入，所以说稍微给我们1到2分钟，然后我们的这一个在线的机器人兴趣讲座，然后马上就开始。好的，现在基本上大家都进来的差不多了。这一次呢，我们主要是由这个 JC Canada， 然后和 Topaz Academic 协办的机器人兴趣讲座。然后这一次讲座呢，全程将由英文来讲座，但是呢，这一次呢，我们涉足的这个群体呢，都是华裔，所以说呢，为了和正规的机器人的这个竞赛和比赛接轨。我们 Daniel 老师呢，他会用英文给大家讲座。如果在课堂当中大家有任何的问题，可以用中文或者英文来提问。Daniel 老师呢，他是 Topaz Academic 的高级教师，是清华大学本科、北京大学和滑铁卢大学的双硕士毕业，多次参加了奥数、编程等竞赛并获奖。曾在2000年入选首届中国队赴美国参加英特尔国际科学与工程大奖赛。精通多种计算机语言，多年的教学辅导经验，所以说呢，这次由我们的 Daniel 老师来给大家带来精彩的这个机器人的讲座。现在我就把话筒交给我们的 Daniel 老师。
Okay. It's my turn now. Okay. Hello everyone. Okay, yeah. Let me share the. Host disabled permission. Okay. So I have a question. Yeah. Okay. So today we'll talk something about robot. Okay. We'll talk something about robot and okay. Let me see the screen. Okay. Okay. Let's begin now. Okay, good. Okay, thank you. Okay, hello everyone. Today I will introduce you something about robot and also something about Lego robots. Okay, because for now we have many different brands about robotics tools or games or toys, but Lego is the most popular one, right? Okay, so first of all, what is a robot? What is a robot? So robot is a machine, especially when programmable. So of course we have different kind of machines. For example, our cars, right? Plane, ship, different machines. They're all different machines. Even the television is a machine, right? But we need to program the machine, right? Then after we program the machine can do something by itself. So it's a robot. Okay. So at least the robot can do something by itself. For example, this one, right? The cleaning machine, right? So there is a program inside, and then this machine can go by itself, right? Okay, and robot can be guided by an extra control device or control may be embedded within. So that means sometimes we have a control, right? Sometimes we just program, and right. Okay, so autonomous and or semi-autonomous. So because there is a program inside the robot, so it can move, it can do something by itself, right? Okay, so for example, here we have some examples, right? They are all different kind of robot. Okay, we can program this, and yeah, this is some basic concepts about robot. Okay, And let's have an example. For example, this is a car, and I'm driving a car. So this car is not a robot because I need to drive the car, right? So the car can't drive by itself. So we drive the car, and we want to keep in the middle of this lane. Okay, we want to keep in the middle of this lane. So, but sometimes maybe we are out of this center line, right? And we can see we are not keep on the center line, and then our eyes will transfer the information to our brain, okay, to our brain, and then okay, we know, okay, we want to go back to the center line. Then our brain will ask our hands to do something, right, to control the car, and then we can go back to the center line. Okay, so if we do all these things with a machine, with a programmed car, okay, then we can have a self-driving car. Now it's a robot because the car can move by itself. Okay, so look at this picture on the left. So we just need some sensors, right? We need some sensors to detect other cars and the lines. Okay, so we use this information to control the car, right? If we don't have these sensors, we just use our eyes, right? We just use our eyes. So yeah, so we just convert our eyes, our hands, and our brains to the machine, okay? And then it's a robot, okay? And then it's a robot, okay? So some parts in this robot. First one, we have hardware and software. Okay, hardware means the things we can see, right? We need to build something, right? The robot. Okay, we have these different parts, and we need some mechanics knowledge to design to build a robot. Okay, for example, different kind of linkage, right? Forward linkage, slider crank linkage, or lever or something like that, right? Pulley, something like that. So and also we need to design a robot. So we have a requirements first, and then we just break down the requirements, and then we choose the parts we need to satisfy the requirements. Okay, this is hardware. This is hardware. And on the other hand, we also need software. Software means the program. The program. Okay, so if we only have the hardware, for example, just like our car, it's a machine, but it's not a robot, right? So we need a program to control the robot. So this is called software. And we also have different kinds of software. For example, the first one is a block-based software, right? This software is an EV3 software, Lego EV3 program. Okay, so we don't need to remember the syntax, the grammar, right? We just clarify the logic, and we just drag the blocks, and we connect the blocks together one by one. Okay, so this is block-based, and the second one is a Python. Okay, it's a Python program. So we need to write some words, some English words, we need to remember the syntax. Okay, but they have almost the same logic. Okay, they have the same logic. For example, different flow control, right? Repeat and different conditions. Okay, the same logic. And for example, they both have variables, different data types, right? Something like this. So in a robot, we have two parts. First one is hardware, and the second one is software. Okay, but if we only have this, it's not enough. So we need input. We need input. Input means we need to know some information from our environment. Okay, we need to collect some information. For example, we use sensors to know the color of other objects, of other nearby objects, and the lightness, angles, distance, motion, pressure, ultrasonic, infrared. So we have different kind of sensor to measure these different things. Okay, for example, we can measure the distance, right? If we are very close to the wall, then okay, the sensor can tell the machine, okay, you are too close to the wall and you need to stop. Okay, you need to stop, and then the machine will stop the motor, right? Yeah, so this is sensors. So we use sensors to collect the information, and then we just pass this information to the machine, to the brain, okay? And also we can measure motor degrees, we can have timers, and we can measure the button we press, okay? They are all called input. They're all called input. Input means some information, okay? Some information we collect, okay? And then we use the information to do something. And then we need to do what? Okay, we need to move, right? We have motors and we need to move. So they are called output. Okay, they are called output. We need to move, and we have two motors, right? And one motor control one side, left side, right side. And if we have two same speed, then the car will move forward at in a straight line, right? But if we turn only one motor, then the car will turn, right? Then the car will turn. So output means we can see the machine is doing something, right? It's moving, it's playing sound, okay? It's changing the light, or for some robots we have screens, right? We can change the display. So they are called output. They are called output. Okay. So this is different parts of a robot. Okay, different parts of a robot. So for a robot, at least we need hardware, software, and output. Sometimes we may don't have input. For example, we just program, and we repeat the work. Okay, so we don't need input, but it's okay. But for self-driving car, then we need sensors, right? We need to detect the distance. Okay, so this is different parts of a robot. Okay, and here there are some different Lego robots. Okay, they are all the official Lego robots. So different system, different machines, different motors. Okay, so the first one is EV3, and the second one is V2. So these two are the most popular ones for now. Okay, EV3 and V2, and so we can see the machine here in the middle, right? Here we have the machine, the hub, smart hub. Okay, and for example, this is a touch sensor. This is a color sensor, and the motor, infrared. So we have output here, right? So we can move, but we need these different sensors to collect some information, right? And then we can tell the machine, okay, it's your turn, you need to move now. Okay, and this one, yes, the same. Here we have a motor, right? We have a motor, and here this is a motion sensor. So we can use this to detect the distance. Okay, to detect distance. Okay, so when we are getting closer to a wall, we can stop. And okay, spike. This is very colorful one. Spike and this 51515. These two sets are quite new. Okay, they are released this year. Okay, maybe. Okay, this year that's quite new specs, but there are also different kind of robots. Okay, so here we have a smart hub. We have a machine here, different sensors, right? This is a motor, sensors, okay, and the motor inside here. This is a motor. So okay, we know the function of sensors are collecting information, right? Collecting information, and then we just pass the information to the machine, and then we use a program to handle this information and to control the motor to do something. Okay, so this is robot, and this one is different because this is from technique side. This one is the largest technique side. Okay, but here we have another new robot machine. Okay, I'll introduce this later. Okay, so for now they are the most popular Lego robot side. Okay, So for a Lego set, we have different kind of Lego set because okay, the young kids loves Lego set, right? But here we can know some different kind of sets. Okay, so the first one, this is just a model. This is just a model, some bricks, some plates, right? We also have minifigures here, right? So we don't have motors. We don't have motors, so we just build it and we display it. And yeah, if you want to play with it, it's okay. But we can't rotate something. We can't move, right? So this is just a normal set. And then this one, you see on the box, sometimes we can see this. That means we have some motors and like this. Okay, so this is a technique set, right? This is a technique set and we have different motors. In total, we have 4 different kind of motors, okay? So this is the medium motor, this is the smallest one. And a large motor, okay, extra large motor and a silver motor. And this one, this is only a battery box. This is only a battery box. And this is a remote control. Okay, remote control is infrared. And this is a remote control. This is a sender, I think. This is receiver. Okay, remote control. So this is a technique set with motors. But how about this one? This is a quite new set now, and we can see the difference here. We can use our phone, our other devices to program it. Now it's a robot. Now it's a robot. Okay, so in this set we use this new hub. So we can download the program, the app, and then we can program it. And then the program will be saved in this hub, and this hub will control the different motors to move. Okay, to control the different motors to move. So the difference between these two is we can program here. Okay, the third one we can program, so we can call it a robot. But the second one is not a robot; it's just a machine, right? We cannot program the second one. So next time when we are looking for a Lego set, then we know we have different kind of machines, different kind of robot. Okay, so this is also the order later we try the building. Okay, so first one we will build a model first, and then we motorize our model. Okay, that means we just add a motor and a battery to the model, and then we can start the motor. Okay, and but because we don't have the smart hub, we don't have these robot machines. Okay, so I just show you something about the robot machines, robot hubs. Okay, so this is just a brief introduction about robot and the Lego robots. Okay, now we have a simple question here. We can try. Okay, here in Lego EV3 model, we can use a color sensor to detect the color of a nearby object. So this is a description about the function of a color sensor. Okay, and this is a kind of what? A input, B output, C movement. Right? So we can try this. Right? Okay, this is the first question we can try. So in this question, we have EV3 model and we use a sensor to do something. So we use sensor to do what? Right? We use sensor to do what? Is that an input or output or movement? Why movement? Right? Okay. Where is it? Where is the question? Any ideas? Sensor. This is the keywords, right? Sensor. Okay. In what model we don't care. What sensor we don't care. And the function of the sensor we don't care. Right? We just have a sensor. So we use a sensor to collect the information, right? To collect the information. So if you want to collect the information, this is input. This is an input, right? Output means the machine can do something. Motors, right? Move, right? Change the color, right? This is output. And input means the machine can receive some information. Okay, so we use sensors to collect information. This is input. Okay. Yeah, but EV3 is a little difficult. Okay, so yeah, don't worry about this. Many different sensors we have. Okay, and now here this is the part we have in this small set. Okay, this is the part we have. So here I will introduce you something about the different parts. Okay, different parts, and because later we need to call this part, right? We need to know the names. First one, wheels. Okay, wheels. Okay, so here we have tires, we have rims. Okay, but it doesn't matter. Okay, tires and rims, right? Rims, and this is panel. This is the smallest size. Okay, we have many other larger size. Okay, this is just the smallest panel, but usually we use panel for decoration. Okay, usually we use panel for decoration. And there are beams. This part, there are beams. Okay, so we have 3 different kind of beams. Okay, generally speaking, this one, they are all some straight beams, right? Here we can have some different angles. Here we have a straight angle, right angle, right? Right angle. Okay, and sometimes we have other angles, okay? Other angles. And these parts, they are half. Okay, they are half beams. Okay, they are half beams. So so they are beams. And the gears. Okay, later we'll show some other gears. Okay, they are gears. And axles. So we use gears and axles to transfer the power. Okay, to transfer the power. And connector. In my opinion, connector is the most important category. Okay, parts category in Lego because there are many different kind of connectors, and if we know these connectors very well, okay, it's very helpful for us to design a model. Okay, and the bush, 2 different sides, right? The red one is a full one, okay, and the gray one is half. Okay, the gray one is only a half. Okay, 2 different sides, and all the others are pins. They are pins. Okay, we also have different size of pins. Some are 3, some are 2, and also pay attention to here. This one, okay, half axle, half pin actually. Okay, half axle, half pin. And this one, the difference between this light yellow and this blue is the light yellow is smooth. Light yellow is smooth. And there are some small things on the blue pins, so it's not smooth. If we put these pins to a beam, okay, we cannot turn these pins easily. But this light yellow, it can turn easily. Okay, we can try later. So just different types of parts. Okay, now we learn 2 new things. First one, if you want to connect 2 beams, this is the most basic operations, right? We want to connect 2 beams. How many different connection points do we need? Actually, at least 2. Okay, at least 2 connection points. For example, the first one, this is a very bad one, right? If you want to connect these 2 beams, okay, first of all, there is only 1 connection point. It's here. Right, so this beam can also turn, right? Can still turn like this, and also this is actually an axle, right? But this hole is a pinhole. This hole is a pinhole. Okay, so if you have other connection points, for example, another pin, okay, it's good, but for now it's not good, right? The second one, the same, only 1 connection point here, right? And only 1 connection point, so they are not stable. They are not stable. Okay, so at least we need 2 connection points. And the second one, different kind of gears. Okay, different kind of gears. So for these gears, we need to pay attention to two things. Okay, first one, generally we can have two different types. First one, bevel gear, and the second one, just some normal gears. Okay, so here we have this big one, right? And this one. So you can compare the difference between these two. The difference between these two. So for the black one, the edge of the tools, they are not right angle. They are not right angle. They are like this, right? They look like this. But for this one, we have right angles on the edge, right? So that's the difference. So the first type is bevel gears. Okay, the first type is bevel gears. And we have different functions of these two different types. Okay, so for now, we just know we have different shapes. Okay, and the second, different sizes. Okay, we have different numbers of teeth on one gear, right? The smallest one is here, only 8 teeth. And the largest one is 40 teeth here. Okay, so different shapes, different sizes. Okay, so different kind of gears. Now, we try another question. Okay, if we want to connect two beams firmly, okay, pay attention, firmly. How many connection points do we need at least? 1 or 2, or the more the better. This is easy, right? Okay, so if you want to connect two beams, we need two connection points at least. Okay, and if, for example, the longest beam is 15, so we don't need 15 pins to connect these two beams. Okay, so the more the better. No, we waste too many pins. Okay, so we just need two. We need two connection points. Okay, now we start to build. Now here we'll have a very detailed instruction, and we just follow the instruction. Okay, and I will build one with you together. Okay, so we finish the model first, and we add the motor, and we can drive the gears. Okay, we can drive the gears later. So okay, let's begin. So for most of the pages on the left, the parts we need, and on the right, how to put them together. Okay, now I'll build one with you. Okay, so the first one, we have two connectors. Okay, two connectors, and easy, right? Here, this is a pin, right? We just put this pin inside this pinhole, right? Okay. And now 2, 3 pins. Okay, 2, 3 pins, blue, 2, 3 pins, and put them in these two pinholes. Right, put them in these two pinholes. And if you want to put this way or this way, they're the same. Okay, it doesn't matter. It doesn't matter. Okay, actually we can have two different ways, right? Okay, it doesn't matter. So put these two blue. Yes. Okay. Next one. Okay. Now we want to use these two green beams. Okay, two green beams. Okay, and then look at here. We connect this beam to this connector, and we have two connection points. Right, two connection points, and then it's a very solid connection. Okay, now it's a very solid connection. So, yeah, next one, two black pins. Okay, two black pins. Okay, the smallest one. Okay, and put them in here. Okay, two different sizes. Okay, two different sizes. Okay, two black pins. And the next one, this short beam. Okay, this is also a beam, but it's quite short. Okay, so only two holes, right? Only two holes. Okay. Yeah, this connector. This connector. Okay, for now, actually we just connect one pinhole to the black pin, right? One pinhole to this black pin. Okay, because later we'll have something other things. Okay, so don't worry about the model. Okay. Now we have two beams, and we need 4 pins. Okay, we need 4 pins. Okay, pay attention. They're different. They're a little different. Okay, we'll see why we need these different things. Okay. Yeah, for the left one, the longer one is on the left side. Okay, for the right one, the longer one is on in the middle. So 1 and 2. One and 2. Okay. Now let's see what's next. Okay. Now pay attention to this. We just put these two to the green beam. So actually here we have 2 blue pins, right? One is from this side, the other one is from the other side. Okay. Yeah, but for each one we have 2 connection points, right? Each one we have 2 connection points. Now half beam. This red one is a half beam. Okay. The thickness is only 1/2 of the normal beam. Okay, you can compare to the normal one. Okay, it's a half beam, and okay, and we have two cross holes. Okay, at 2 ends, but we don't have cross holes. Okay, we don't have cross holes on the normal beam. Okay, and this axle is 3 long. Okay, 3 long, the shortest one. Okay, we also have a 2 long axle, but it's red. Okay, this light gray, they are all numbers. Okay, 3, 5, 7, 9. They're all numbers, they are light gray. And for the even numbers, 2 is red. 4, 6, 8, 10, 12. Okay, they're black. So black. So in this side we have 4. In this side we have 4 long. Okay, we have 1 is black, and we have a yellow one. The yellow one is 5. Okay. We also have 2 short brown. Okay, there are 3. The 2 short brown axles, there are 3, but the difference between the brown ones and the light gray is there is a top. There is a top on the brown one. Okay, there is a top, but the gray one, no. So we just put the 2 axles in the axle hole. Okay, cross hole. And then here. And then here. On these 2 connectors, we have 1 cross hole, right? We have 1 cross hole, so we just put the axles in. Okay, we just put axles in this cross. Okay. So if you want to put the 2 axles in the black connectors first, it's also good, and then connect the right one. Okay. Actually, different ways. Okay, different ways. So later we'll have the other red one to connect to the other side. Okay, the other side. So So for now, we know the two black connectors are also very solid. Okay. Even though we have only one connector to the one pin to connect to the green beams, but we use these red things, these two red half beam to hold the position. Okay, so it's also very solid. Now we use the big gear. The big gear. Pay attention. We have two half bushes. Okay, two half bushes. So we just put the yellow axle in the middle of the gears and the two gray bushes. Okay, two gray bushes. Okay, so for this one we need to put a black gear, okay, through the connector here. Here we have a hole here, right? We have a pinhole. So we just put the axle through this pinhole, okay? And then we need two bushes first, and then the small gear, and then another bush, okay? Another bush. So in total we need three bushes, okay? So this light yellow gear is also a half gear, okay? It's a half gear. But the black one is a full one, right? It's a full one. The light yellow is a half one, okay? So three bushes and one gear, okay? And one gear. Now, because in the middle of the connector, okay, it's a pinhole, but we use axles to put this in the pinhole, so we can rotate the gear, right? Okay. Now, two beams, okay, two beams. Okay, this is 7. Okay, 7, and we need six black pins, 6 black pins. Okay, and pay attention to which pinhole we need. Okay, the first one, the third one, and the fourth one. Okay, the first one, the third one, and the fourth one. First one, third one, fourth one. Okay, this is the body of the bottom of the hovercraft. Okay, next one. Oh yeah, this 3 short beams, and 6 pins, Okay, 6 pins. So for the middle one, the green, we need 2 blue. Okay, so because there are two pinholes on this beam, so we just put this pin side in this beam. Okay, pins in this beam, and then we can leave this axle outside. Okay. So the two black beams, so 1 blue pin and 1 black pin. Okay, 1 black pin and one black, 1 blue. Okay, 1 black, 1 blue. Now another beam, the 3 long beam. Okay, and the 2 black pins. Okay. Okay, so we just put these things like this shape. Okay, and later we'll use some other things to connect these beams. Okay, to connect these beams together. Okay, and yeah, just like this. This is the body of the shape, right? Shape. Okay. Next one. Okay, we use these two L. Okay, these two small L. So the two green beam is here. Okay, this is the 2 green beam. This is the 2 black beam. This is another 2 black beam. and this is 2, 2, 2. And here, this is the 3, 1. Okay, yeah, this is the bottom. Okay, this is the bottom. We just connect this. Connect this. Pay attention to the L. We have a cross hole. We have a cross hole, right? We have a cross hole. But here, for the black pin, we have only one pin, and the other one is a cross. Okay, but here we already have a pin to connect this, so it's good enough. Okay, it's good enough. This is top. Okay, this is bottom. Okay, this is top. Now, next one. Okay, top, bottom. Okay, so we connect the 7 beam to here and here. Okay. Okay, 2 panels, 2 small panels. We have 2 more black pins on each 7 beam, right? So just put these 2 panels on these 2 beams. Yeah, this is the body of the ship. Okay. 2 panels. This is the smallest panel you see. We have different size and different numbers. Okay, index number. Okay. Now who can tell how to put this? Actually, we have a 3 axle here, another 3 axle here, right? And on this panel here, we have cross hole and the cross hole. Okay, cross hole and the cross hole. So we just put these axles into these 2 panels. Okay. One axle, the other axle. Okay. Now we build something. This. Okay. This is it's also a kind of beam, right? And the 2 bushes. Okay, 2 bushes. So this is a 3 axle. 3 axle. Okay, and 1 bush on this side, the other bush on the other side. Okay. So you can put the bush on the axle first, and then connect to the beam. Okay. Okay, here we have 2 different sides. Okay, so these 4 parts. Okay, this gear, these 4 parts, this gear. Okay, pay attention to the red one. To the red one. Okay, it's on the right side. Okay, so the red one and the yellow gear, they're on the same side. Okay, on the same side. And pay attention to these 2 gears. This one is a brown one. This one is a gray one. Okay, the difference is here. We have a top. We have a top. So here the brown one and the top is on the bottom. The top is on the bottom. Okay. And after we finish these 2 parts, okay, actually we connect these 2 gears here, right? We connect these 2 gears. So for this one, okay, the brown axle, we need to put the gear on the axle first, and then this way, and then 2 bushes. Okay, so put the gear on the brown axle first, and then from the bottom, and then 2 gray bushes on the top. Okay, the other one is easier because there is no top on the gray axle. Okay. Okay, so next one, we need one more black pin. One more black pin. Yeah, here, one more black pin. Okay. So now let's connect this to the body. Okay, so we use this black pin to connect to the 3 beam. Okay, to connect to the 3 beam. Okay, it's on the bottom. Okay. Now it's done. Now it's done. Okay. So here you can take pictures about your model, or you can also design some other models with this size or other level size. Okay, and you can also upload the pictures to the links in the group, right? Okay. Yeah. Okay, and then you can share your model, right? Okay. So this is done. Okay. So for this model is done. Now here we have a gear on the bottom. Okay. So if we just put this on the, yeah, but the table is quite smooth, so it's a little to drive this gear. Okay. But if you have some other kind of surface, maybe it's better. Okay. And you can drive this gear, right? You can drive this gear, and then the power will be transferred to the black gear, Okay, to the black gear. Now pay attention to this. Pay attention to this. Okay. We use 2 bevel gears to connect like this. It's a right angle. It's a right angle. Okay. Now the third question. You already finished the model. Now you observe your model carefully. So we have 1, 2, 3, 4, 5 gears, but we have some different kind of gear connection. So how many different gear connection methods can you find? So that means 1 gear is here, 1 gear is here. We connect these 2 gears together, right? 2 gears. Okay. So when we turn this one can turn. So this one is a kind of connection, right? And we have some other connections. So how to connect 2 gears, different positions, right? How many different connection methods can you find in your model? So this is a very small model, but for the gear connections, it's very good. Okay. So how many different connections can you find? You can try. Okay, you can try. And this is the topic we will discuss next class. Okay, how to connect gears. How to connect gears. Okay. The answer is 3. The answer is 3. Okay, we have 3 different gear connection methods in our model. Okay, and actually there are 3 most popular gear connection methods in our models. Okay, actually in most of our models, at most 3. Okay, 3 is enough. And so here I'll show you these 3 different connections. Okay, I'll tell you. Okay, now I'll show you. First one, this is parallel. We have 2 axles like this. This is parallel connection. And the second method is this. This is what? We have parallel, so we have perpendicular, right? This is right angles. we have right angles. So for the first one, okay, we don't change the direction, right? But both this way. But the second one, we change the rotation direction, right? We have a right angle, right? We have a right angle. And the third one is this one. This is called concentric. Okay, so you observe your model. We have 3 different connection methods. Okay, we have 3 different connection methods. So next class we'll practice these gears again. Okay, so now let's motorize the model. I said the motorize means we just add the motor and then we can turn on the motor and drive the model. Okay, so the first one, the medium motor. Okay, the medium motor and 2 black pins. Okay, on the left side and right side. Okay, this one and this one. Okay, left side and right side. 2 black pins. 2 black pins. So yeah, where is the other black pin? See. Okay. And put it in this bin. Oh yeah, I see. We need to take this. We need to take this out. Okay, we need to take this out first. Okay, so we need to take this part. Actually, we take this part off. We take this part off. Okay, and then we add motors. Okay, and then we add motors. We don't need that thing anymore. Okay, we can break it. We can break it. Where is the black pin? Okay, next step. Okay, we use a brown axle here. Yeah, here. Okay, brown axle, and we use this gear. This is also a bevel gear, right? A bevel gear. Here on the edge, we don't have right angle, right? It's not right angle, so it's a bevel gear. It's a bevel gear. So we put the gear on the axle first. When it's here, and then we put it in the middle of the motor. Okay. So this is a very popular way to connect motor and gear. Okay. Next one, we need 4 of these connectors. 4 of these connectors and 4 pins and 4 pins. Okay, 1, 2, 3, 4. Okay, we can see this one. Okay, so 12 parts in total. 12 parts in total. Here, this end. Okay, 12 parts in total. Black connector and 4 3-pin and 4 2-pin. Okay. Okay, I just got a very good question. Okay, I'll answer the question later. So after this, let's put these 4 parts on the machine. So this is the 3 long black pin. Okay, 3 long black pin, 3 long black pin. Actually, for this end is useless, but we don't have black pins anymore. Okay, so just leave this. Here we will use these 4 black pin, blue pins. Okay, we'll use these 4 blue pins like this. Pay attention to here. In total, we have 1, 2, 3, 3 pinholes on each side. And we need, these two, okay, these two. Okay, so if we use these two, we can connect this black gear and the small white gear. Yellow, right? Small yellow gear. Okay, if we use these two, so we cannot connect the two gears. Okay, we cannot connect the two gears. Okay, so we just put the motor and these beams this side. Okay, now it's done. Now it's done. We just add one motor to the model. We just add one motor to the model. Okay, this is the black gear, and this is light yellow gear, and we connect these two. We connect these two. So we can drive the big gear. So the final purpose is to drive the big black gear, right? The big black gear, okay? And then we can connect to the battery box. Battery box. Okay, just like this. So we need six batteries. Okay, 6 batteries. And this switch, okay, two different ways. So the motor will have two different rotation directions. Okay, they're both good. Okay, now you can try. You can turn it on, and when you turn it on, we will have a green light here. Okay, we'll have a green light here. Now we finish the motor here, but we don't have a program. We only have a battery, and then we can drive the motor, right? So we can only run the motor and then run the gears. Okay, so if we want to program it, for now, we can't. We need to use, for example, we need to use V2 or V3 machines, smart hubs. Okay, this is V2 smart hub, and this is a V2 motor. It's different from this Technic motor. Okay, it's different. Okay, so if we use this machine, we can program it. You see the motor, the shape of the motor is quite similar, the same connection. Okay, but we can connect to a machine which can be programmed. Okay, and we can use a software on our laptop. We can download it from LEGO official website. So we use V2 2.2 education. Okay, we use this software to program. It looks like this. So we have different blocks. They have different functions. We have different colors. Okay, different categories. I will introduce something more about the program. Okay, later. So for example, the green blocks. Okay, we have some motors here, right? The first one, power, so we can control the rotation speed from 0 to 10. And the second one is rotation time, running time. Okay, so some kids love to set it to infinity, right? 10,000, 10 million seconds, so it won't stop. Okay, so the second one is rotation time. We can control the rotation time, and we also have 2 rotation directions. So we just drag the blocks. Okay, in the middle, we connect these blocks one by one, and then after we press this button, then the program will be run. Okay, one by one. So this is an example. Okay, so for this example, the first 3 blocks. Okay, we set speed 7, and then counterclockwise. Okay. Yes. Okay, counterclockwise, and then we run it for 3 seconds, and then we change the speed to 10. We increase speed to 10, right? And then clockwise, we change the direction. We change the speed, and then we run it for 5 seconds, and then we stop the motor. Okay, so if you have EV3 set and this program, we can program it. But for now, if you only have the battery and this motor, we cannot program it. Okay, and also we have many other functions. So And also, this software is the easiest one, okay, in different, okay, Lego sets, Lego robot sets, okay, but we can also have a very complicated program. Okay, this program was for a competition, a video competition, okay, a robotics competition. So we can have many other blocks, okay, and yeah, but we just program this based on the requirement, and then we analyze the requirement and we design the program. Okay, we design the program. But for now, we just know how to build a solid model and how to use motors. Okay, it's good enough for now. And later, if you want to learn how to program, we can have many other different kind of courses. Okay. 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 For now, the first model is done. Okay, and I already have a question. So if you have two motors, okay, so one motor this side, the second one this side, so we control two different wheels. And if you have two different speed, for example, this is faster than the right one, then what will happen? The car will turn. Okay, actually we can have different ways to turn our car. Okay, for example, this one is one way. We have two different rotation speed. So the car can turn. And also for our cars, okay, the real cars is called steering, right? We change the direction of the two front wheels, and then we can turn. Okay, so for some the technique side, official technique side, so usually we use this way. Okay, to turn the car. But yeah, it must be a very large site. Okay, so but some students want to, they use two motors and they connect two motors with an axle. If we build a model like this, then this is not good, because the reasons, okay, we use two motors because we want to have two different speed, and then we want to turn the car. But if we connect the two motors together, if we have two different speed, okay, we will break the motors or we will break the axle, right? Okay, so if you have two motors, just run these two separately. Okay, Okay, and yeah, that's a good question. Okay, any other questions?
Daniel 老师，鉴于这个时间的原因，对，鉴于时间的原因，然后咱们今天的这个课程就到这里。然后，如果是家长朋友有什么问题的话呢，都可以在这个群里边给大家提出来。这样的话呢，我们可以改进。好的，今天的课程呢就到这里了。我们谢谢我们的 Daniel 老师。然后呢，咱们下一周的周二，然后咱们再见。